Okay, class, we're down to the sympathetic division of the autonomic nervous system. We've already done the parasympathetic system. Now, the sympathetic division is also called the thoracolumbar division. Why? Because it's in the thoracic region of the spinal cord and in the lumbar. It's from T1 all the way through T12, and then L1 and L2 of the lumbar region. The sympathetic division is much more complex than the parasympathetic division. It innervates all the visceral organs of the body like the parasympathetic, all the ventral body cavity organs, the pupils of the eye, and the salivary glands, but it also innervates the smooth muscles of peripheral blood vessels, and we're talking about basically arteries with their huge tunica media, the skin structures, sweat glands, erector pili muscles in the skin, and of course the blood vessels of the skin, and it goes to the adrenal gland. These structures the parasympathetic does not go to. And the sympathetic division contains more ganglia than the parasympathetic. I know it sounds confusing, and probably when we're going through it, it will be confusing, but as you keep seeing more of it, hopefully it'll start making sense. So let's start with what you know. You know that sympathetic preganglionic neuron cell bodies are located in the lateral horn of T1 through L2. So the first visceral motor neuron cell bodies are within the CNS, and they're in the lateral horns T1 through L2. Remember, this is where the visceral motor neuron cell bodies are, in the lateral horns. In the sympathetic nervous system, T1 through L2. These preganglionic axons, they travel with the somatic motor neuron axons. Remember, somatic motor neuron, his cell body is in the ventral gray matter. So this preganglionic sympathetic axon is traveling with the somatic motor neuron axons in the ventral root. It's going to go into the spinal nerve, just like the somatic motor neuron axon, but it's going to leave the spinal nerve through an off-ramp called the white ramus communicans. There's two of these they look like off-ramps. This one's the white ramus, this one's the gray ramus. You do not go through the gray ramus. You are going to go through the white ramus, and we'll talk about that a little bit more. White ramus. This is called the white ramus because remember, this preganglionic axon is all myelinated. It is all myelinated. Remember, myelin is white, so it's going to go through a structure called the white ramus. Now, let's have a look at this picture. This is going to add to it. So we said the preganglionic axons are going to leave through the ventral root. They're going to go into the spinal nerve, and they're going to enter through the white ramus communicans. This is the white ramus. And it's going to enter into this structure. This is the sympathetic chain ganglia. This is the sympathetic chain ganglia. You'll be seeing lots of pictures of this. These are ganglia. There's going to be two ganglia where our preganglionic sympathetic axons could synapse. One of those ganglia is going to be in the sympathetic chain ganglia. So sympathetic chain ganglia. So we are entering through the white ramus, and now we are in a ganglia. This whole structure is called the sympathetic chain. There's a chain of these ganglia all together. Here's another view of that sympathetic chain. So we're going to, this is showing you getting on through the white ramus right here. This is T1 through L2. Those white rami are only on levels T1 through L2. I don't know if I mentioned that already, but they are. So you can only get onto the sympathetic chain ganglia through the white rami T1 through L2. So here they're showing you the white rami. This is white rami. Here's a sympathetic chain ganglion right there. Now, it does not matter where you're going to go in the sympathetic nervous system, what ganglia you're going to synapse in. You have to first get on the sympathetic chain. Get on this sympathetic chain. You have to. So, these white rami are connected to spinal nerves T1 through L2. They have a good direct connection to spinal nerves T1 through L2. How many spinal nerves do you have? You've got 8 cervical, 12 thoracic, 5 lumbar, and 1 coccygeal. You've got 31 pairs of spinal nerves. So, this preganglionic sympathetic neuron, its fibers, its axons are going to be getting on the sympathetic chain ganglion only through the white rami communicans that are located only at levels T1 through L2. Don't know if I'm explaining that right. Here's T1 through L2. This is the only place where you're going to have those white rami communicans. The only place you're going to have the access route to get on the sympathetic chain ganglia. Now, once you're on the sympathetic chain ganglia, it's just like an elevator. If you get on right here, once you're on this chain, you can go all the way up. You can take the elevator all the way up to C1 spinal nerve, or you can take the elevator all the way down into the sacral region. So you can travel up and down the sympathetic chain. Does that make sense? That sympathetic chain is on both sides of your vertebral column. So far, so good, I hope. Now, we have gray rami communicans too, we talked about. These gray rami communicans, they are at every single spinal nerve. So every single spinal nerve, all 31, they're going to have gray rami. You're going to get access to every single spinal nerve through these gray rami. So let's look at the other ganglia. We said we're going to have 2 different ganglia, just like we had 2 different ganglia in the parasympathetic. We have 2 different ganglia in the sympathetic nervous system, 2 places where our preganglionic neuron can synapse with. First is going to be in the sympathetic chain ganglia. We already saw that. This is the sympathetic chain. running from C1 all the way down on both sides, sympathetic chain ganglia. It is paired, and this sympathetic chain ganglia, via the gray rami communicans, it is connected to every single spinal nerve. Now, there's the other ganglia that it can synapse in, is what we call prevertebral. Pre means in front of, and we're talking about vertebral in front of the vertebral column. But basically, it's in front of the abdominal, it's in front of the abdominal aorta. Here's the aorta. Remember, the aorta, abdominal aorta, is sitting down here. So here we have the abdominal aorta, and all these little spots, these clusters, these are all prevertebral ganglia. This is a nice sympathetic chain ganglia on the sides. It looks like a little chain. These are not paired. They are just little clusters of ganglia, basically located on just right in the front of the abdominal aorta. So let's have another look at these ganglia so you can kind of figure out where they are. So here is the sympathetic chain ganglia. You can see these bulges. Now these bulges are corresponding to every single spinal nerve on both sides. They're a little bit different in the cervical region, but basically just think of them as connecting to every single spinal nerve. Our prevertebral ganglia are going to be somewhere in front of the vertebral column on the abdominal aorta, right here, prevertebral ganglia. So far so good. You've got the sympathetic chain ganglia, and you got these prevertebral ganglia. Those are the two places where our first visceral motor neuron can synapse with. Now, this is your worksheet. So if you don't have your worksheet, you need to stop the video and you need to get your worksheet, because we're going to be filling out this part of the worksheet, and it does you no good just to listen to me blabber without you having this and writing it down yourself. So we're going to go through this together. So I want you to have this worksheet. So here is a cross section of the spinal cord. This section right here in between these dotted lines is going to be T1 through L2 region of the spinal cord. Above this dotted line is going to be the C1 through C8 region, spinal nerves C1 through C8, and below this is going to be L4 S5 region of the spinal cord. So let's label this. Number 1, you already know. This is the lateral horn. Number 2, ventral horn. Number 3, ventral root. Number 4, dorsal root. Number 5, the dorsal root ganglion. Everything so far you know. Number 6, that's your spinal nerve. 6A is the ventral ramus. 6B is the dorsal ramus. Number 7 is the gray ramus communicans. Number 8 is the white ramus communicans. Number 9 is the sympathetic chain ganglia. We've got them all up and down. We have lots of them. Sympathetic chain ganglion. Number 10 is the splanchnic nerve. Splanchnic nerve. It is in the abdominal pelvic region. Splanchnic nerve. Number 12. So number 12, this is the sympathetic chain ganglia right here. There is going to be a little offshoot that is not a white or gray rami communicans. This is just going to be called a thoracic sympathetic nerve. And this is going to actually take our nerve fibers, our sympathetic nerve fibers, into our thoracic cavity to go to our heart and lungs. So that's number 12. Number 13. Here we have our gray rami communicans that are connecting to spinal nerves L3, 4, 5, S1, S2, S3, S4. These are connecting to spinal nerves, the gray rami communicans. Remember, there is no white rami communicans below L2. Same thing up here. We have a gray rami communicans connecting to a spinal nerve in the cervical region. So this you have to know. Hopefully it's starting to make sense. Now here's a diagram we'll kind of work through this too. So here is the intervertebral foramen, right, where those spinal nerves are coming out. Here's our spinal nerve. Here's our white rami communicans. Here's our gray. Remember, gray is the first one, white is the second one. Here's a sympathetic chain ganglion, one, but these are all sympathetic chain ganglia. And this whole structure is a sympathetic chain. It looks like a necklace, a chain. Here is our ventral root. Here's our dorsal root. Here's our dorsal root ganglion. Spinal nerve. So hopefully you're starting to see a little pattern. This one's from your worksheet too. So now you recognize the sympathetic chain ganglia, right? On both sides, right next to the vertebral column. Here is a spinal nerve right here. This one is the gray ramus communicans. This is the white ramus communicans. Remember, we enter through the white. Enter through the white to get into our sympathetic chain. Now I'm just going to show you a close-up of this so you can kind of see what a mess the sympathetic chain and prevertebral ganglia look like. So let me see if I can move this. Come on, why is it not moving? There. So I don't know if you can see, but see these white dots here? Can you see these white dots coming down? They're coming all the way down. This is the sympathetic chain coming down. It's going all the way down into the sacrum too. And it's going to be on the other side too. Now we're going to get to our prevertebral, which are in front of our abdominal aorta, but this doesn't show you the abdominal aorta. But see these big blotches, these white blotches? These are our prevertebral ganglia here. Just a mess. These prevertebral ganglia are a mess. I just wanted to show you what they look like. They're just a mess. These are some rules. They are universal truths that you must remember. First thing, you must get on the sympathetic chain. No matter where you're going, if you are in the part of the sympathetic nervous system, you have to get on that chain. White rami communicans only exist at levels T1 through L2, and they are connecting to the spinal nerves at that level. That is how you're getting on the sympathetic chain, is through these white rami at levels T1 through L2 of the spinal nerves. Why are they called white rami again? Because the preganglionic axons that enter them are myelinated. They're white in color. Gray rami communicans exist on all 31 spinal nerve levels. Every spinal nerve is connected to the sympathetic chain by a gray ramus. The sympathetic chain exists to carry some of the preganglionic fibers from the T1 through L2 levels up to the neck in the cervical region, or you can take the elevator down into the lower sacral region. Remember, once you're on the sympathetic chain, you got on through the white rami somewhere at T1 through L2. Once you're on this chain, you can ride up and down the chain to get to where you want to go. And there's going to be a gray rami connected to every spinal nerve. Hopefully, it's kind of making sense. So, once our preganglionic sympathetic fibers have arrived onto the sympathetic chain, they can do one of four things. There's 4 different pathways that you need to know. So if you have your worksheets and you printed them out, you can do these pathways with me too. The first pathway is going to take us to skin structures. So we're talking about the erector pili muscles, the sweat glands, and the blood vessels in the skin. So we are going to use our spinal nerve pathway to take us to our skin structures. So I'm not going to read through this because it's easier just to show you. So let me show you. So basically, to get to the skin structures, we're going to use a spinal nerve to get us to our skin structures. So this is on your worksheet. So you need to draw this so you can kind of figure it out. So, oh my gosh, look how I spelled erector. Oh well. Erector pili muscles. Sweat glands and blood vessels, the blood vessels of the skin. So, this is T1 through L2. This is T1 through L2. So, write that down. T1 through L2. So, we are in the lateral horn at levels T1 through L2. We are going to leave our preganglionic axon fiber is going to leave. It's going to go into the ventral root. It's going to go into the spinal nerve. And then it's going to enter through the white rami, the white ramus, singular, through this white ramus. And it's going to synapse in the sympathetic chain ganglia. So remember, this is what are ganglia? They're a collection of cell bodies. We have a bunch of visceromotor our second visceral motor neuron cell bodies in these ganglia, right? These are full of visceral motor neuron cell bodies, our postganglionic neurons. So we're going to synapse with our second visceral motor neuron. We're going to release acetylcholine, and then this postganglionic axon is going to leave through the gray ramus, and now he's on the spinal nerve. And that spinal nerve can take him anywhere because spinal nerves go throughout our entire body. And he is going to go to our erector pili muscles, our sweat glands, and the blood vessels of the skin. This is going to be what's the neurotransmitter here. What is this neurotransmitter? Norepinephrine. What one was this? What's the neurotransmitter here? So that way you can put it into acetylcholine. But if we have this whole chain, what if you need to start sweating up in your neck? What are you going to do? You're going to get on the sympathetic chain. You're not going to synapse here. You're going to take the chain up. And then you can leave through a gray ramus, say close to C1, the C1 spinal nerve. You can synapse way up here, and then your postganglionic axon can leave through the gray ramus up here, get on the spinal nerve, and go to your neck so you can start sweating up in your neck region. Or you can go, you don't have to synapse here, you can say, I need to start sweating in my feet. You're going to go ahead and get on the white ramus. You're not going to synapse. You're going to go all the way down. And then you're going to go all the way down, and then you're going to synapse in a sympathetic chain ganglia close to your feet. And the postganglionic axon will leave through the gray ramus and go through the spinal nerve close to the feet. So hopefully this makes sense. Basically, you're just getting on through the white, leaving through the gray. On through the white, leaving through the gray. The gray takes you back to the spinal nerve. You do not have to just synapse here. You can synapse wherever you want to go. You've got the whole chain up and down. You can get off on any gray ramus. I don't think I mentioned it, but it's called the gray ramus because those axons are unmyelinated. So white ramus, because the axons are myelinated. Gray ramus, the axons that leave through that gray ramus are unmyelinated. So here's a book illustration of that. So going to the skin, here we're going to start. Our preganglionic neuron is in the lateral horn of the spinal cord at levels T1 through L2. We're going to leave through the ventral root, get onto a spinal nerve, enter the sympathetic chain ganglia through white ramus communicans right there. We're not going to synapse here. We're going to head on up the chain. We're going to synapse at this ganglion right here. We're going to release acetylcholine. This postganglionic neuron, its axon, is going to leave through the gray ramus, hop on a spinal nerve, and that spinal nerve is going to take us to our destination. It will release norepinephrine at the target organs in the skin: erector pili muscles, the sweat glands, and the blood vessels. This is going to be norepinephrine. What will it do to the blood vessels of the skin? Vasoconstriction. What will it do to the sweat glands? You'll start sweating. What's going to happen to the rector pili muscles? They're going to stand up. It's called piloerection. These hairs are going to stand straight up. So the pathway to the skin, you are getting on the sympathetic chain through the white ramus, and you are going to be synapsing on the sympathetic chain, one of the sympathetic chain ganglia. And then you're going to leave through the gray ramus communicans, and you can get to any spinal nerve you want. That's pathway number 1 to skin structures. Oh, I drew this one so you could see it. So here we're going to skin structures, but we're going to go down the chain. Here we are, the lateral horn, T1 through L2 level. We're going to get on the sympathetic chain through this white ramus communicans. We're not going to synapse in this sympathetic chain ganglia. We're going to take it down. We're going to go down the chain, and we're going to synapse at a lower level sympathetic chain ganglia. That's in levels L3 and below. We're going to release acetylcholine. We're going to synapse with the postganglionic neuron. His axon is going to leave through the gray. There is no white. There's only gray here. He's going to leave through the gray to get to skin structures and release norepinephrine. Remember, there's only gray that's connecting to spinal nerves C1 through C8, and there's only gray connecting to spinal nerves L3 and below. So hopefully that makes sense. Now, the second pathway we can take, if we are going to go through to our thoracic cavity. So far we've only gone to the skin. We have not gone into a ventral body cavity. If we are going to go to the thoracic cavity, and basically we're talking about going to the heart and lungs, we are going to be using, I forgot that structure. What was that? Is this number 12? Yes, we're going to be using number 12, the thoracic sympathetic nerve, right here. So we are going to start in our lateral horn at levels T1 through L2. We're going to go, that preganglionic axon is going to go through the ventral root into the spinal nerve. It's going to enter the sympathetic chain ganglia through the white ramus right here. And it will go up. It's going to synapse with our postganglionic neuron. It's going to release acetylcholine. The postganglionic neuron axon is going to leave through that thoracic sympathetic nerve. And that's just going to carry it to either the heart or the lungs. And it's going to release norepinephrine at those structures. What's the action of the sympathetic on the heart? It's going to increase the heart rate and the strength of contractions. On the lungs, it's going to dry up secretions and bronchodilate, open up the air tubes. It's going to work on the smooth muscle of the air tubes. It's going to relax them. They're going to dilate up, let in more air. So, remember, to get to thoracic structures, thoracic cavity structures, you are not going through the gray. You are not getting on a spinal nerve. You are synapsing in the sympathetic chain ganglia, and you are leaving through this thoracic sympathetic nerve to take you to the heart or the lungs. Not too bad, right? So let's have a look at this diagram. This is from a textbook showing us how we're going to get to our thoracic organs. So here they're showing you two preganglionic neurons. Let's follow the green one first. So we're going to start in a lateral horn, T1 through L2 level, go through the ventral root, go through the spinal nerve, enter the sympathetic chain through our white ramus communicans. We're going to synapse in the sympathetic chain. We're going to release our acetylcholine to our postganglionic neuron. The postganglionic neuron, its axon, is going to leave through the thoracic sympathetic nerve, and it will go to the target organs of either the lungs or the heart and release norepinephrine. This other one, the gray one, same thing, lateral horn, ventral root, spinal nerve, entering the sympathetic chain at the white ramus. We're going to not synapse right away. We're going to go up the chain, and we're going to synapse at this sympathetic ganglion up here, release acetylcholine. The postganglionic axon will leave, and it will go to our target organs through the thoracic sympathetic nerves and take us to either the heart or the lungs and release norepinephrine. So, our third pathway. To get to our abdominal cavity structures, we are going to be using what they call a splanchnic nerve. We are going to be synapsing in those prevertebral ganglia that are located in the abdominal aorta. So let's see how this path works. Where are we starting? The lateral horn, T1 through L2, lateral horn. Our preganglionic neuron cell body is there. Our preganglionic axon is going to leave through the ventral root. It's going to go to the spinal nerve. It's going to leave the spinal nerve through the white ramus communicans. It's going to enter the sympathetic chain. It's going to enter the sympathetic chain ganglia, but it is not synapsing in the sympathetic chain ganglia. It's not synapsing anywhere in here. It is just using it to get to this splanchnic nerve that's leaving the sympathetic chain ganglion right here. The splanchnic nerve is carrying it towards the prevertebral ganglion. It's going to release acetylcholine. It's going to synapse with the postganglionic neuron. The postganglionic neuron is going to leave, and it's going to head off towards any of these organs, any of these abdominal organs, stomach, liver, gallbladder, small intestines, large intestines, the internal sphincter of the large intestine, of the rectum, the bladder, the external genitalia. So, to get to any abdominal organs, you are going to enter through the white ramus, pass through the sympathetic chain ganglia, take the splanchnic nerve, which is going to take you to the prevertebral ganglia. Then you're going to synapse. Remember, this is all myelinated. All this is myelinated. Then you're going to synapse with your postganglionic neuron, and you're going to leave this postganglionic axon is going to leave the prevertebral ganglion, and it's going to synapse with any number of organs. and it's going to release norepinephrine. Not too bad? Not bad. So here's a book drawing of what I showed you. Our preganglionic axon is going to leave through the ventral root, spinal nerve. It's going to leave the spinal nerve through the white ramus communicans, enter the sympathetic chain ganglion, but it's not synapsing. It's going to go ahead and travel through that splanchnic nerve to take it to the prevertebral ganglion, where it's going to synapse. The postganglionic axons, same thing, is going to leave, and it's going to go to any number of those abdominal organs, and its neurotransmitter will be what? Norepinephrine. What's the neurotransmitter here? Acetylcholine. This is all myelinated. This is unmyelinated. Postganglionic axons are unmyelinated. So far so good. That was the third one. We only have one more left. Our last pathway to the adrenal gland. Remember, the parasympathetic does not go to the adrenal glands. These adrenal glands are located on top of the kidneys. This is an endocrine gland. Remember, adrenal is telling us it's on top of the renals. It's on top of the kidneys. This is an endocrine gland. This is a one motor pathway. This is the only one that gets a one motor pathway. It is not going to be synapsing with a second visceral motor neuron. We are going to an abdominal organ. The adrenal gland is in the abdomen. So we are going to be using our splanchnic nerve to get us there. So this is what's going to happen. Here is our first visceromotor neuron. Its cell body is in the lateral horn, levels T1 through L2. The first visceromotor neuron, axon, is going to leave through the ventral root into the spinal nerve. It's going to enter the white ramus communicans. It's going to bypass the sympathetic chain. It's not going to synapse in the sympathetic chain ganglion. It's going to go through the splanchnic nerve. It's going to bypass the prevertebral ganglion. It's not going to synapse in here. This is all the first visceromotor neuron axon. This is all myelinated. It will then reach its target organ, which is going to be the adrenal gland. It's going to synapse with the adrenal gland. It's going to release acetylcholine. The target organ, the adrenal gland, is then going to release norepinephrine and epinephrine straight into your blood. This is an endocrine gland. Endocrine glands release hormones that are going straight into your blood. So it's released norepinephrine and epinephrine. Norepinephrine is just going to be converted quickly into epinephrine. Epinephrine is a massive stimulant. You are now adrenalized. You've got so much adrenaline. Why is it called adrenaline? Because it's coming from your adrenal glands. You are adrenalized. If you've ever had any kind of sympathetic massive overload like you got in an accident, you are shaking because you have so much adrenaline. That is because you have now released epinephrine straight into your blood. Your whole body is now activated. So these are the 4 pathways. Go through them again if you don't understand them. Draw them. That would really help. When you draw them, it really does help. If you are going to skin structures, you are going to be getting to those skin structures by spinal nerves. You are going to synapse in the sympathetic chain ganglia, and you are going to leave through the gray rami. And you're going to hop on a spinal nerve that's going to take you to the skin structures. If you are going to the thoracic cavity, to the heart and in the lungs, you are going to enter the sympathetic chain ganglia. You are going to synapse in the sympathetic chain ganglia, and you are going to leave through a thoracic sympathetic nerve that will take you to the heart or the lungs. If you are going to the abdominal cavity, you are going to be traveling via a splanchnic nerve into the prevertebral ganglion. So you're going to enter the sympathetic chain. You're going to leave through the splanchnic nerve. That splanchnic nerve will take you to your prevertebral ganglion, where you will synapse with your second postganglionic neuron. And then you'll go to your target organ. The adrenal pathway, it's a one motor pathway. You are going into the sympathetic chain. You're not synapsing there. You are leaving the sympathetic chain through the splanchnic nerve. Splanchnic nerve's taking you through the prevertebral ganglion. You're not synapsing there. You are going straight to the adrenal gland, and you're going to synapse on that adrenal gland, and the adrenal gland will then release epinephrine into your blood. So draw those. If you draw them, you will understand them. Seems complicated, but it's not. This is what they're going to look like in books. Here is your spinal cord level T1 through L2. That is how you're going to get on the sympathetic chain. That is the only place where they have these white rami communicans. So white rami communicans connecting you to the sympathetic chain. No matter where you're going, you got to go on that sympathetic chain. If you're going to the skin structures, you are going to synapse in the sympathetic chain and leave through the gray rami to get to a spinal nerve to take you to the skin structures. If you're going to the heart and lungs, you are going to synapse in the sympathetic chain somewhere, and you're going to leave through a thoracic sympathetic nerve to get to the heart or the lungs. If you're going to any abdominal organ, you're going to get on the sympathetic chain, T1 through L2, and then you're going to leave through a splanchnic nerve. These splanchnic nerves are going to take you to one of these prevertebral ganglia, that are in front of the abdominal aorta. And then you're going to leave the prevertebral ganglion, and you're going to synapse, and then you're going to leave and then go to your target organs in your abdominal cavity. Except the adrenal gland, it's going to get on the sympathetic chain. It's going to leave through a splanchnic nerve. It is not going to synapse in the prevertebrals. It's going to go straight to the adrenal gland. And here they're showing you this adrenal gland one is not dotted. That means this is all first visceral motor neuron axon. The dotted ones are the postganglionic axons. So these are all postganglionic axons. Postganglionic axons. The only one that's not postganglionic, because it's a single motor neuron pathway, is the one going to the adrenal glands. So I know this seems like a lot, but it's not really. It's just 4 pathways. Just do one pathway at a time and then move to the next one. Here's your sympathetic chain ganglion. This is cool. It just shows you it's going all up and down. Your first visceral motor neuron cell body is located spinal cord regions T1 through L2. White rami, T1 through L2. This is showing you gray rami, connecting to every single spinal nerve. All these gray rami are going to be taking you to spinal nerves that are going to take you to your skin structures. If you're going to thoracic organs, again, you're going to get on the sympathetic chain. You are going to synapse, but you are going to leave the sympathetic chain through these thoracic nerves. This postganglionic fiber will then synapse in the lungs or heart. If you are going to an abdominal organ, you are going to get on the sympathetic chain. You are not synapsing on that sympathetic chain. You are going to the prevertebral ganglia here, somewhere in front of the abdominal aorta. You're going to synapse there, and then you're going to, your postganglionic fibers will go to their organs in the abdominal pelvic cavity. The only one that's not shown here is the adrenal one, but that one's easy. So this we kind of went over with parasympathetic. The location of the ganglia, remember we have 2 ganglia, types of ganglia in the sympathetic. We have our sympathetic chain ganglia that are real close to the spinal cord, and our prevertebral ganglia that are right in front of our vertebrae. They're actually in our abdominal aorta. Parasympathetic ganglia, they are far from the CNS. They are far, far away. They are lying within, either near their organs that they innervate, like the terminal ganglia, they're close to their organs that they're going to innervate, or they're intramural ganglia, they are within the organ themselves, within the organs themselves. So we look at the relative length of pre- and postganglionic fibers. Start with the parasympathetic. The preganglionic fibers are long. Remember we said the vagus? Vagus is long. It is going from the brainstem all the way down into the abdomen. It's going to synapse in an intramural ganglia within the organ, and that is short. The postganglionic axons are short. So preganglionic is long and parasympathetic. Postganglionic are short. Here's just showing you. Parasympathetic, the preganglionic axons are long. Postganglionic are short. It's the opposite for the sympathetic. The sympathetic preganglionic axons are short. The postganglionic axons are long. And the neurotransmitters. What's being released in the parasympathetic? At the synapse with the second visceral motor neuron, acetylcholine. At the target organ, acetylcholine. Sympathetic. At the synapse in the ganglia with the second visceral motor neuron, acetylcholine. At the target organ, the synapse is going to release norepinephrine. This is our last picture. Aren't you glad? I'm sure your head is hurting. T1 through L2. These are the white rami connecting you to the sympathetic chain. Here's showing you skin structures. You're going to leave through the gray. You can leave through the gray on any spinal nerve, all the way up here or all the way down here. Once you get on the sympathetic chain, you can go up and down that chain and go to your skin structures through any gray ramus. I'm not going to go through this again. This is a pretty nice picture. So I'm going to leave you with my little rap song. You're probably falling asleep by now. Let's see how. Oh my gosh, this is an hour long. Oh my God. Let's leave it with a big bang then. So this is sympathetic. Have you ever seen a bear and been scared? Your CNS will tell you what to do. Get on the sympathetic train and take a ride through the train chain. Ensure your survival. Protect your brain. Get on the white rami T1 through L2. Your brain will tell you what you need to do. You can leave through the gray or take a ride up and down the train chain. Run faster than a myelinated axon, sending signals from your brain, keeping you free from the pain. That's the power of the sympathetic chain. I know, it's bad. So we're done. We're done. Bye.